for three bearing fixes. Three bearing fix is again a means of achieving a position. So we're going to be plotting these three given lines of position on the chart. One challenge you may find as you start working on this chart is locating each of these points. Just take your time with it. In the classroom we can point them out, but eventually you'll get familiar with where these charted objects are. And what we're looking to achieve here again is a fix, which is a good or a known position. Keeping your work neat and working maybe on a piece of scrap paper rather than in the margins of your problem set. For this first problem, we're going to have line of position 1, which corresponds to this beacon 117. We're going to have line of position 2, which corresponds to this building in the vicinity of Lauderdale. And we're going to have line of position 3, which corresponds to the Tungati River. So I'm just going to go ahead and abbreviate each of those. And we're given three bearings, 350 degrees, 310 degrees, and 273 degrees. Those are given to us as degrees magnetic. They're given to us as magnetic rather than compass because it's most likely that you've used a hand-bearing compass to achieve these values, and you won't have a known deviation value for such a compass. So, remembering our mnemonic, true, virgins, make, dull company, we're going to go ahead and convert these to true, but again, we're going to be able to avoid dealing with deviation and compass in this problem. It's still true that if we were working this way, we would want to add whiskey, but in this case, we are going to be working backwards, so we'll subtract any west variation. And if you look here at the top of your problem set, in order to match your answer key, we're going to assume that all problems on this chart have a 25 west degree variation. Variation, again, is the difference between Earth's magnetic field and the true North Pole. This data in real life is given to you on the chart, but for our problem set, you'll be given that value. Some simple math here. You can do it in your head, but I'd recommend doing it with a calculator, since I can make simple math errors in my head far too frequently. So we're going to go ahead and subtract 25 from each of those values. I think I know these ones well enough that I'll just go ahead and pencil them in, but double check your math work to make sure you've got no simple errors. Taking these three values, we're going to go ahead and locate these objects on the chart. We're looking for beacon 117 in the vicinity of Sheffield Beach. That's right up here at the top. We're looking for this building in the vicinity of Lauderdale and the mouth of the Tungati River. That's not quite a small point on the chart, but just right here where the river mouth meets the coastline is our third bearing. And what we need to do is draw a line in each of these directions, originating from each of those charted objects out into the ocean, and we're going to look for where they cross. So, setting aside that work for a moment, somewhere where you can still see those values, let's grab our parallel rules. It's important to be accurate with these tools, and you can also be pretty clever with them. We need to find bearing 325 first. So here's 320, here's 330, and right here in the middle is 325. We're going to go ahead and line up our rules with the middle of the compass rose and that bearing 325. Again, precision is important here. You can put your pencil right in the middle and use that to help maybe pivot the other arm of the rule until you get to the correct bearing, but be precise about that measurement. And you may utilize the edge or that black line in the parallel rule. Now, a little trick with this problem is when you measure 325, you're already pointing at this building, but it's important to remember that this bearing corresponds to beacon 117. So don't draw that line here. Instead, any parallel line to this will be bearing 325, and we want to slide it up until we get to this beacon at Sheffield Beach. Let's use the outside of the parallel rule to draw this line. Otherwise, you may get a parallax or parallel error with the non-rounded side of the ruler. And this is a line of position, so again, our notation is to put an arrow at the end of that line. Draw it nice and long at first too, because we don't know where our fixed position is yet. And I might even write 325 degrees in at the end of that line so that I know which line of position that is. All right, let's efficiently repeat that process 2 more times. The next bearing is 285, so center of the compass rose, and 285. This corresponds to our building, so we're going to walk that up. Careful not to slip. Once you get to the building, we'll draw in that bearing. Again, arrow, bearing 285. That's what it should be. And last time, bearing 248, and that's going to come up to the river. Okay, now you'll notice when you complete this problem that you do have a crooked hat, meaning there's a triangle formed by these 3 lines. You can be very confident about your position if they all cross perfectly, but in reality you're likely to get some uncertainty here. And what we want to choose is the point nearest danger, and that's going to be our position fix. Now, if there were a rock or a danger marker nearer to this corner, I might choose that corner instead. But for this example, the most dangerous feature to a ship is going to be the landmass and the risk of running aground. So this will be my fix. And in this example, all they've asked us to do is plot it. You can use your answer key to compare. And you might also be asked for a latitude and longitude of that position, in which case you can utilize your rules to accurately measure off that latitude and longitude.